Yeah, welcome to this webinar, Python for Algorithmic Trading and the AI Machine. Thanks again to our host here, QUANTACT webinar series. And I dive into my slide deck, to which I can share, of course, the link, all hosted as you might be used to when you follow us along on our pages. I have prepared as well a quick introduction, although everything has been said already mostly. I will then discuss briefly what I understand under the Pewdie myth in finance, moving on towards data-driven finance and in particular AI-first finance, which sets the stage for my little Python demo, where I will use machine and deep learning algorithms to come up with ideas for algorithmic trading strategies. I will then show, based on a demo mainly, how to deploy such a strategy, basically exactly the same strategy on our AI machine. If you're interested to learn more about Python for algorithmic trading, I will have a few words also about our certificate program. My introduction is pretty quick. Maybe here, in addition to what has been said already before, you might want to visit our main page, tpq.io. Everything centered around Python for finance training. We run a platform, open source, books, certification, events, and services for companies on almost global scale. If you're interested in my talks, mainly, it's not a private page, hilpisch.com. It's a page also about Python for finance, but there I host all my talk resources like Jupyter Notebooks, slide decks, and so forth. Visit hilpisch.com and have a look there, all for free. Also YouTube videos, for example, for most of my talks. Actually, I've written 3 books on the topic, and the major one is in the middle. It's Python for Finance, and I'm pretty happy that the second edition came out just before Christmas, 4 years after the first edition was published in print. It has grown a little bit, so a few more pages, different topics, and in particular, I think this is interesting for the audience today, maybe now a complete part with 3 chapters about Python for algorithmic trading there as well, making use of machine and deep learning techniques to derive strategies, discussing topics and showing how to deploy strategies for automated live trading. So pretty happy. It was much more effort than I thought in the first place, but now that it's out, I'm pretty happy it's on my shelf. And yeah, you should have a look. All Python 3, 3.7 even, and the latest and greatest out of the field in this regard. I'm also happy that our topic is an international one. Here you see the Chinese versions of derivatives analytics with Python, as well as the first edition. Second edition is not yet out, I would guess, as a translation. But of course, the topic that we are concerned with today, and in general, we as a company, is an international one. Python is used in every corner of the globe these days in the financial space. When we started out well more than 10 years, almost 15 years ago, going our first steps with Python for finance, people said, well, you're crazy to use Python for finance. Now everybody, small or large, is doing it. What do we understand under the Pewdie myth in finance? Here I have a short excerpt from The Economist, where I for the first time encountered this term, the Pewdie myth, and it's used in the context of physics theories, and in particular with regard to the grand unified theories, which is kind of the holy grail in physics. But here the major insight is given a bunch of experiments and results from empirical studies. Physicists must conclude that many of these wonderful theories are only this one thing, wonderful, but not mostly of any practical purpose. So many books, papers have been published, was written in this article about these GUTs, grand unified theories, but none of them has proven to be of any use. And I think in finance is a little bit different. The beauty there usually lies in the simplicity. And when we have a look at the cornerstones of economics, I have here 2 of my favorite books, 2 books that I used when I was studying at the university and when I was writing my PhD in mathematical finance. Arbitrage pricing, I think, is a success story. Expected utility, beyond economics, has basically no practical application or purpose. It's not used, for example, let's say by Spotify to recommend new songs, or by Netflix to this end. Equilibrium theory is also its shortcomings. And then we come to the two things that drive many areas in the financial literature: normal distributions and linear relationships. And I think most of you know that there are not too many quantities in finance that that are normally distributed. We see completely different distributions. I have a few results in this regard, and not too many relationships in finance are linear. So two of the most commonly used assumptions are basically not seen. So the Pewdie theories that rely on these assumptions from the outset are a little bit faulty, maybe. So no wonder that hardly any of the wonderful theories have strong empirical support. On the other hand, what is for us algo traders, what is not good news, if you like, is that the theories that say that basically by analyzing historical data, you cannot gain any benefit compared to any other investor who doesn't do the analysis at all, namely the random walk hypothesis and efficient market hypothesis. They have strong empirical support. They are among those who've gained prominence exactly due to this fact. And if we think this through and we say, well, if financial quantities in financial markets are random walks, then where's the point in analyzing historical data or doing technical analysis or trying to do algorithmic trading at all? Basically, we should just sit on the fences and do passive investment. So this is what we are up against. So this is to a large extent not good news, because much of the theory is normative and not positive. And the theories that have a good support on the empirical side, they speak against any benefits from doing algorithmic trading. So now let us get a little bit more to the present and fast forward a little bit. Most of the things here actually have their origins starting in the 50s and going through the 60s, 70s, 80s. But today we have a different outset. Most of what is happening these days is data-driven. I used to work providing Python training for one of the biggest hedge funds in the world in New York, and they always said, please, Yves, don't speak about finance. We don't have financial engineers. We only have data engineers. And this is already a few years back, and is one of the most successful hedge funds out there, multi-billion, and still growing and fast growing. And they have been data-driven from the outset. And these days, I can really judge what they meant back then. Don't come around the corner with your financial theories. Just speak about data and data science with Python. This was a few years ago. And when we look back in history, basically, even 100 years ago, people picked up the news and read about what was happening in the markets, whatever markets meant at a particular time. I still enjoy reading Financial Times or whatever I can pick up when I board the airplane. These days, usually I read it here on the web. It's the same content presented electronically. So no trees have to die anymore in general. But these days are over since decades as well. Most traders, analysts, portfolio managers, they sit in front of their terminals and have access to all the data in a more systematic fashion. Think of the Google for financial data. Of course, this is what the standard is since decade. Bloomberg, Thomson Reuters, or these days it's called Refinitiv with the Icon terminal. Thousands and thousands of users in the financial industry paying decent subscription fees to get easy access to all the data that is out there. But the next wave, of course, is already there. And this is what I call data-driven finance, that you open up something like a Jupyter Notebook or your shell or whatnot. You type in a few Python. It's not actually commands. You have your object and you call a couple of methods, passing in a few parameter values, and you get back here tick data. You can't read tick data out of the newspapers. You can't read tick data properly from a terminal. You can have a look at it, but once you get beyond a certain point, let's say 20,000 points, 200,000, 2 million points, for a typical FX pair, you have some 2 million quotes per week that you need to crunch if you want to go to the tick level. So this is nothing that you want to print out or as a human being want to read, but the machine doesn't care if it's 2,000, 20,000, or these days even 2 million or 20 million data points. So the machine can do that. And this is where I say, well, finance is mostly data-driven these days and not that much driven by theories, which to a large extent still rely in their origins on end-of-day data. And the same holds true for unstructured data as well. So we work since quite a while with Thomson Reuters. We work since last year with Dow Jones, and we have programmatic access, let's say, to billions of news articles. And be assured, even if I or if you enjoy reading the newspapers, the machine is much faster, and it's much quicker and better in identifying relationships, themes, can provide summaries, and can read through, let's say, 1,000 articles in the same time that you have read maybe a paragraph. So of course, machines have an advantage there as well. It's not the same advantage, I would say, in relative terms as with regard to numerical data, but still, I mean, machines read the news, and think of Google once again, what they do in terms of natural language processing. This is amazing. And we can do it if we like with our regular desktops or whatever machine you use on a daily basis as well. Not too big machines are required in this regard. The Python ecosystem, fortunately, I mean, as part of my talk, Python, the ecosystem provides you with basically everything that you need in this regard. So we are well equipped when we make use of Python with regard to tools and the packages that we have there. Not even listed here a single NLP package, for example, Excel, if you want to combine the Python power with Excel, for example, in a professional capacity, all is there, and basically all is super powerful and basically available for free. AI first finance. We know that part of the success of AI these days is the availability of larger data sets. So big data and artificial intelligence are closely interlinked by the need of many algorithms for large quantities of data. With end-of-day data, when you think it through, let's say you have 250 trading days, let's say for the Apple stock per year, times 10, you have 2,500 points, times 3, so 30 years make up for 7,500 data points. This is small data for most machine learning algorithms. Not for everyone, not for every algorithm, I'm saying, but for many it is. And when you then have a look at what I was showing before, here the data is for a quarter of an hour, you get 2,000 tick data points. So for an hour, roughly 8,000. Roughly per hour, you get 8,000 ticks. This is roughly the same amount of data that Apple generates over 30 years with regard to end-of-day data. So this is how far we have come with regard to data, and this makes possible the application of AI algorithms, machine learning, deep learning algorithms that previously haven't been applicable. Also, of course, software and hardware play a role. It's not only data, but more on that later on. Here, a nice book. If you've never heard about the Technical Singularity, this is probably a nice book to get started with. And I'm just picking out here this one quote, which says, today's algorithmic trading programs are relatively simple and make only limited use of AI. However, this is sure to change. And part of my talk is about artificial intelligence. Of course, there are many algos that trade stocks, for example, out there, but not too many algos, even these days, even today, make use of artificial intelligence in this regard. So we need to differentiate between algorithmic trading per se and AI-powered algorithmic trading. So there are many execution algorithms, for example, that have completely different goals compared to, let's say, an AI-powered trading strategy. So here it says, well, only limited use of AI, and it's still the case, I would say. And the next part is the interesting from my point of view. Artificial intelligence is beneficial in any domain where patterns have to be found in large quantities of data, and effective decisions have to be taken on the basis of those patterns, especially when the decisions have to be taken rapidly. So here we are now in the domain of pattern recognition, and everybody active in the financial markets doing day trading, algo trading, of course, is somewhat concerned with patterns. And I'm not the biggest proponent nor the biggest opponent of patterns in this regard. The only thing that comes out of the quote, and this is completely my thinking as well, if there is something in patterns, be assured the machines are much better in spotting these patterns than we human beings are and in reacting to these patterns. And don't make a mistake that many people do, in the sense of that machine learning doesn't mean that the machine learns the pattern that you teaches the machine. The machine figures out the patterns on its own. That's the beauty of it. So this is all myth. This is also Pewdie myth that you say, well, this particular pattern, let's pick out the first one. This is a breakout pattern and this is a buy signal. Who knows that? I will show you data. This is all Pewdie myth. This is belief. This is normative. I believe in that. I believe that this and that. My colleague told me. The professor, the teacher, the trainer, the lecturer told me, blah, blah, blah. This is all belief, but the machines, they have the potential. You have the data, you have the machine, you have the algorithms. You can figure it out on your own if you find something in the patterns there. So that's the beauty of AI first finance. We don't need to fall into the trap of picking up a book and say, well, this is what somebody else believes and what others believe, and now I need to believe it as well and try my best. You can ask the machine what the data says, and this is what is then data-driven plus AI first. Here, one of the first books about the topic, Advances in Financial Machine Learning. Can only recommend that you pick up a copy, maybe with Safari if it's online. The basic conclusion here in the introductory words is that econometrics might have been a good tool for a while, but these days machine learning is what you need to use in order to find alpha. So there are long passages about alpha and how alpha availability has evolved in markets. Basically, it is like, back in the days, 10, 20 years ago, it was kind of easy. These days, you need algorithms that are better suited to pick up the much smaller alpha opportunities that are still available. The big ones have mostly vanished. Everybody is doing the same factor-based trading, and there is no big deal to be made anymore. So this then leads to what I call AI in finance or finance. This is AI first finance. From the normative economics, where people started with their assumptions, normal distribution, linear relationships. They came up with simple and elegant theories like the capital asset pricing model, factor models, and so forth. But the problem is hardly any supporting evidence. The supporting evidence that is there is, unfortunately, for theories that say, well, there's no prediction possible at all, like the random walk hypothesis. Here we get back to positive economics. We have a look at the data, at the relationships themselves that we want to discover. We don't think too much. We analyze rigorously based on newly available data sets, based on newly available and these days easily usable algorithms. And even if it's not that beautiful, if it's better suited to trade in the markets, I'm more than happy to use it. I personally can live with a black box. Not everybody out there in the world can live with a black box due to compliance and legal reasons, but basically I could live with it if it brings me money. I'm happy if I understand how it works or not. One of the traditional analogies is like, not everybody in this world knows about the special relativity theory and the general relativity theory, but both are necessary to build a navigational system, to understand how GPS is supporting your navigational system. Everybody is using these days navigational system, be it just Google Maps on your iPhone, but you can use it even without understanding the full extent of all the theories that are involved there. And this is how I see it here. You don't need to understand everything in order to successfully apply. We need different packages and technologies. Maybe for proper large-scale deep learning, we need graphics cards and so forth. No question here. But still, this is available, and everybody who is a little bit involved in gaming, has anyways, I guess, an NVIDIA graphic card back home that can be used. Like if I have a need to use it, I use the one of my son, and because I don't have a GTX or whatnot here in my office. So little Python demo is now in order. So I've spoken a lot, but I think I can make my points clear, hopefully loud and clear, based on the Python code. Let me open my Jupyter Notebook. At this point, I'm going to share the link so that you have still access to the slides. Give me 1 second so that I can copy links. I will put them in chat there. But you see also here the link to the slides and also there to the HTML version of my Jupyter notebook. All right, let's get started. Python for algorithmic trading, use of machine and deep learning for algorithmic FX trading. So I'm doing a few imports. This takes a little bit because I'm importing quite a bit. A couple of changes are there, therefore I used warnings. So why wonder and why FX? I have this in the slide deck as well, so I will jump over this part here. And revisit this when we talk about the AI machine. So I'm using Wonder F and FX trading platform, and why FX and why Wonder, again, I will, after the demo, revisit when we talk about the AI machine. I'm getting connected here to the API. I'm working here with Euro, US dollar, FX, and I'm reading in the bid-ask prices for just a couple of days. So I start here on a Monday, go to Wednesday. So this is from this week, so pretty current. I didn't do that much tweaking. You see, we get here for 1 minute bars, we get 2,804 points. So we have full access to all the historical data here via the Wanda API. The average spread is 1.3, 1.4 pips, what we see there. And I'm going to calculate here the mean spread relative to the mid price. This would be my proportional transaction cost. This is 0.012% are my proportional transaction costs, and there are no other transaction costs involved in this trading thing. So when we have a look at the data, here, just the starting data, I stick to the closing price. This is Euro US dollar exchange rate starting on Monday. And I can also plot the full data set here. You see I'm using cufflinks, makes it interactive. The week hasn't been, well, I don't know, too good, too bad. At least the exchange rate is coming down over the course of the week. So the question would now be, what does it mean for today? If we analyze the previous 3 days, what does it mean for today, for example? Now let us first see, and this is where I said, well, we have in general strong support for efficient markets. And here I have a few lines of code to illustrate that given standard definitions of efficient markets, we have efficient markets. One interpretation of efficient markets, or the random walk hypothesis, one possible, is to say the best predictor for tomorrow's price is today's price, or for the next minute price is the price in the current minute, or whatever the time interval is. So here I'm working with 7 lags. We have 1 minute bar data. I'm calculating here or creating 7 columns with the lags. I do a linear least squares regression, set the print option, and I just want to show you this chart here. So based on a linear least squares regression, I have 7 lags, and I would like to use the 7 lags of price data, Euro US dollar exchange rate, to predict the next minute rate. And what you see is indeed what the typical definition is. So the only important number we can conclude here is the most recent lag. So again, another example, Apple stock. When I know the price for the Apple stock today, it doesn't matter what it was the day before, 2 days before, 10 days before, half a year before. The best predictor for tomorrow's Apple stock price is today's Apple stock price. You can try it on your own using the same approach. And here for the Euro US dollar exchange rate, it's the same. 7 lags I'm using, but the only relevance for my prediction here is found in the most previous lag. So this is what is considered support for the efficient market hypothesis. Actually, it's also the defining characteristic of a random walk. So the history is irrelevant, just the current price is what is done. So now let's visit patterns. Investopedia writes, so when I speak about these topics where I have strong opinions, I usually try to find some quotes. And here I like these ones. Investopedia writes, chart patterns look at the big picture and help to identify trading signals or signs of future price movements. The theory behind chart patterns is based on this assumption that certain patterns consistently reappear and tend to produce the same outcome. This is the point, that they consistently reappear and tend to produce the same outcome. So in my slide deck here, these are just the things, that they reappear, and when they reappear, that they produce the same outcome. So that's the idea of patterns. The process of identifying chart patterns based on these criteria can be subjective in nature, which is why charting is often seen as more of an art than a science. This is what I meant with belief and normative. I have an assumption. So, but with machine learning, the beauty is that we can analyze the data. And analyzing the data for me is now as follows. I now work with returns data. Instead of the price lags, I take the lagged returns. I know I go a little bit fast over all this, but this is not a training session. This is just to show how it works. And I create 7 lags now. And when I have a look at my data set, right now, you see I have 7 lags, lag 1 until lag 7. And I only differentiate whether the most previous movement was positive or negative, whether lag 2 was positive or negative. So when there is a +1, it means that the return was positive. And 2 minutes back, it was positive. 3 minutes back, it was positive. So you see, I come up with patterns here. I have 7 lags, and basically we can calculate this for sure. 2 to the power of my lags here gives us 128 patterns. So with what I'm doing here, I have already 128 patterns that I can analyze. Here in my slide, these are 8, 16, these are 20 patterns only. And I think for a human being to trade 20 patterns is already quite a bit. For a machine, 128 patterns, it's kind of nothing. So a machine can easily deal with 1,000 or 10,000 different patterns. That's not the thing. I mentioned that we should get back to positive economics. Positive economics meaning that we should consult the data and not hold too strongly to our beliefs. And in that sense, we can get started simple. And this is what I would recommend to everybody out there. When you believe in these patterns, again, I'm not providing any investment advice. This is by no means advice. I'm the Python guy, and I'm showing here Python stuff. This is just example based and illustrative. But if you believe in something, first have a look at the plain vanilla data. And plain vanilla data, I'm going to show you this, can be as follows. Here I'm analyzing, for example, just 2 lags. And I said, well, whenever I have seen down, down, or down, up, or up, down, or down, down. So these are the 4 options that I have with 2, only. So this is like this. It's not 2 to the power of lags, it's 2 to the power of 2. I have only 4 combinations, and these are the 4 that I'm analyzing. Here I see already kind of a frequency distribution. Up, up is happening only 592 times. You see, this is the least frequent occurrence here. So up, up happens 592 times. The others happen a little bit more often. This is not a big surprise, because when we have a look at the data, you see this is going down, 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 down. So on average, we are going down, and we would be surprised that up, up would be the most frequent pattern that we spot there. But we can do a little bit better. So let us now do accounting here. The question for us is not how often we see down, down or up, up. The question for us is, when we see down, down, how often do we see then another down or another up? can we read something out of this pattern? Is this predictive in the sense of 2 times down? Now, I don't know, with 60% probability, the price goes up. And we see indeed here, based on the frequency, an upwards movement is more likely here in the frequency sense than a third downwards movement. So this is what the data says. This is no artificial intelligence. This is only about frequency and frequency distribution. And I can provide you with the frequency probabilities here as well, frequency ratios. So here you see with 13.09% probability, we see 3 downwards movements in a row. And we also see again that the upwards movement after 2 downwards movement is more likely than a third downwards movement in a row. So let me get to an advanced analysis. This uses a little bit of trickery with regard to the data frame, but it shows the data slightly better. Now we see it more clearly. And when we have a look at it, now you see it exactly. This is already pretty close to how algorithms work. I do it here based on 3 lags, so 1 lag more. When I go up there, you see I'm using 3 lags, and with 3 lags, I have now 2 to the power of 3. You can calculate everything on your own. We have already 8 combinations there, and this is the frequency, and here we get the probabilities that I've calculated. So you see, after 3 downwards movements, the upwards probability is 51.5%. And here you see the complementary probabilities. Let us have a look where we see the highest probability. The highest probability we see here. This obviously seems to be the best trading signal that we can identify here. After we have seen 3 upwards movement in our data set, of course, this is all relative to our data set, we have a 58% probability for a downwards movement. This seems to be kind of something we should look at. But this is only frequency. Let's go to the machine learning and deep learning ones. So now I'm running through a few machine learning algorithms. I'm pretty sure many of you have seen some of them already in our programs, in our training programs, courses, and materials. We cover these in detail. Here I'm using logistic regression. And I fit now my historical lags and try to do the prediction. And the accuracy is not too good. So here you see it's just 48.3%. It's not too good. Gaussian naive Bayes is another, as they call it, baseline algorithm. You see no parameter at all. And this baseline algorithm is even slightly worse. But now we come to the interesting ones. I would, of course, have liked to have here an accuracy score of well above 50%. Something like, I don't know, 55 upwards would be nice. Here I'm using support vector machine with 3 different kernels. And you see suddenly this RBF thing, 55%, polynomial 51.3%. So I have 3 different models. The only parameter difference is in the kernel. And I will later on pick this one because this is the best one I could identify. Now, deep neural network. This takes a little bit to train because this is iterative, 1.3 seconds. And let us have a look at the accuracy. This is similar, actually. The accuracy here, 55.1%, and here it's 55, rounded 0.3%. It's even slightly better. But the accuracy score, it's what is called the hit ratio. It's just one side of the coin. The other one is which intervals we get right. And here I do some vectorized backtesting. I will repeat the exercise with the AI machine. You see here in red the big disclaimer: no transaction costs, only in sample performance. This will change on the AI machine, but this gives us a first glimpse at the power, the predictive power of such an algorithm. So here I get started with the RBF SVM. But you see already one big issue. Here I'm figuring out the number of trades. the number of trades, and you see 1,268 trades. So probably this strategy would eat up any profit based on transaction costs. So this is just a word of caution. But we are not dealing with transaction costs, so life is simple here. We are dealing with an idealistic world. But what is kind of nice, if we neglect the transaction costs and only in sample, these are two major drawbacks, huge drawbacks. But nevertheless, let us have a look at the data. You see the green line is my original instrument, the passive benchmark investment. And the blue one is the deep neural network classifier. And the yellow one, or orange one, if you like, is the SVM model. And you see both outperform strongly here under these simplifying assumptions. And compared to the simplifying assumptions typically applied in finance, I don't have too much of a bad taste here when I do it, because it's a starting point. It's a benchmark. It's a starting point. We know we need to take care of these issues, but this will be done on the AI machine. But here you see, instead of losing, let's say, a little bit, we gain some 2.5% over the course of the days analyzed there. So now you might say, well, I believe in my strategy. And then many people get to this point and then they say, well, how can I trade this strategy? To whom can I connect? To which broker? And how do I deploy it? And how can I run it with risk management in place and so forth? That's the big thing. And this is where the AI machine comes into play. And this brings me to the second but last part there, the AI machine. And the AI machine is similar to, let's say, a self-driving car. A self-driving car is built to drive on its own, autonomously through a city. But basically, the route is not fixed. It's not like with a train, that goes like on a fixed track. The car is steering itself through cities or on motorways. With the AI machine, it's similar. We don't really care which strategy and which instrument, but nevertheless, it should be automated, right? So AI-based algo trading machine and self-driving car. Basically, in finance, it's much easier because we don't need to build a physical machine, and basically we cannot harm people. So this is the two major differences to self-driving cars, and we don't have any geospatial problems. The one thing is to build something physical. The other one is to have the sensors to recognize the outer world. So maybe we would say three major differences in this regard. But when we think in terms of algorithmic trading, you have seen already what I've been doing. I worked with data, euro, US dollar exchange rate, 1 minute bars, any time that you pick, features and label, time series features, economic indicators, directional movement, machine learning, support vector machine, DNN classifier. I used everything. I didn't do training and testing nor validation, but that's easy to add. Backtesting, I did only vectorized backtesting. I did a little bit of visualization. And now the big thing, deployment comes. If you know what you do, it might not be the biggest thing, but I would say for 90 or 95% of the people who want to do algo trading, this is the biggest obstacle. Technology-wise and data-wise and platform-wise, we have everything in the Python ecosystem, in the financial markets, even for retail traders to get started. That's not a big deal. It's all there. DigitalOcean, you can deploy your stuff in the cloud, get started with $5 per month. Highly professional infrastructure at very low cost. Free data from FXCM, even tick data, free data from Wanda, streaming, historical, it's all there. But the big thing is if you want to deploy that stuff, deployment here, DevOps skills, 24/7, thousands of lines of code are required. And you can discuss with our team. When we started out building the machine, we were a little bit more optimistic how fast we could reach certain milestones. But the deployment gap and the last mile problem is indeed a serious one for many people. I recently spoke to a PhD who is working in full-time capacity machine learning and coding. And he said, Yves, my trading code, the algorithm is 150 lines only, but my deployment code for cryptocurrency trading is 25,000 lines of code. So this is the difference here. A few hundred lines of code versus thousands of lines of code. So I can only confirm the story from our experience. And the AI machine basically covers the bridge from the data input over features, labels, machine deep learning, backtesting to deployment. And we could write here, and this is what makes me most proud, one-click deployment. And I will show you the one-click deployment. Why Oanda and why FX? So you should go, when you have a look at the slides or at the Jupyter Notebook later on, you should go through these points carefully. Most people have some history doing day trading, investment and whatnot, and they come to the algo trading side driven by the products that they have been trading before. But in algo trading, if you take one thing with you, technology and APIs first, then the product. So platform with the technology and APIs is the first thing. So many people say, well, I want to trade stocks algorithmically. This is not the same simple thing. First of all, find the right broker, IB, for example. Then you get started with IB. Then you encounter many issues when you want to do cloud deployment with regard to the API and so forth and so forth. So you should go through these points. Transaction costs, fully symmetric markets in FX, low transaction cost, simple cost model, high leverage possible but not required, all typical orders, everything straightforward, good trading apps, full data history for all instruments, free data, pair and basket strategy is also possible. So there are a bunch of things that speak for, at least if you're a retail trader, to maybe reconsider your ideas about what you want to do in algo trading, product-wise and via which platform. So I show you now the AI machine in action. So maybe, I don't know, maybe I need to log in again here. I might be logged out. I get started with the strategies part. So you recall my little SVM model here that I've been training, and this is the one that I'm going to use now. I have implemented this already here, and you see here it's all template based, meaning we have a Jupyter Notebook that is running in the backend, and you can define based on a standard strategy template. You can define your SVM strategy, as I've called it here. So that's my name. This could be, I could have called it Yves strategy or whatnot. Then you define your parameters. You can come up with new parameters. You see here training test state, which machine learning techniques, which kernel. So I have set already the parameters similar to what we had before. And then you go down, and I cannot go through the details, but this is basically the same Python code that we used before. We also have the choice here between logistic regression, naive Bayes, and SVM, all freely definable. If you want to add another algorithm, this is also easily done. And down here, maybe I want to highlight this, the directional trading strategy. This is where the short and long positions are taken. So, and you see this is, as the strategy stands here with all the validations taking place, etc., pp. It's some 100 lines of Python code. And this defines a directional strategy. And you see the largest part is getting the parameters correctly. So I would say here now, save and checkpoint when I'm finished with the definition of my strategy. So again, I get started here with the research. I said, well, yeah, now I've got my strategy. I want to deploy it on the AI machine. So you have written the code down and you have saved it. And here, SVM, it says uploaded. Then you go to backtested models. I can do a backtest here. Let me check. Euro, yes, dollar, SVM, 1 minute bar, number of lags, 7, proportional transaction costs as calculated, SVM, C, the C factor, 0.5, the kernel, RBF. So I could change this now to linear or whatnot. Training start, training end, 4th to 5th. Testing start, testing end. I said before we will do train test here. So let me backtest the model. You see the upper first now says here in progress. This takes a little bit. Now it's completed because in the backend it retrieves the data, does the backtesting. Now I show the in-sample results here for the backtesting. This is now for the 2 days, 4th and 5th, that we have backtested. In-sample performance looks similar to what we have seen before. Here we now have also out-of-sample, and the out-of-sample also looks promising. So we are dealing with relatively small numbers, but this doesn't include at this stage any leverage or whatnot. So I will start the strategy with 20 leverage. So I said, well, this all looks good, exactly as I wanted to have. And now I come to, I mentioned it before, to the button that makes me most proud of the work of our team there, of the AI machine team. Namely that I say, well, this all looks good. Now let's get started trading this whole thing. And I say, well, maybe we trade 2,000, stop loss distance 2%, take profit 4%, leverage 20%, number of bars to toggle when a stop loss happens, 2, number of allowed stop losses, no hedge required. And I can say trade immediately, for example. And then I say add the model. And how long did it take? I don't know, 20 seconds. And exactly the strategy where I started here, here, with my interactive research, where on the platform I have formulated the strategy in the form of a Jupyter notebook. I have done the backtest. I have clicked go live. And in the live model, we should hopefully see it. Yeah, it's running here. You see, I can show you here in my account. This is now the live account. I'm trading euro, US dollar, 2,000 units. And the first trade that was placed is short. So this is the proper account. And here you could also do some charting or chart support or what. I have here the 5-second euro US dollar running. So we see more or less real-time data. And here is the euro US dollar. I might change it to 1 minute. For example, this is now the bar that we trade. So you can change here, of course, between 5 seconds, 1 minute, depending on what you want to see. Now I have on the left-hand side the 5 seconds, on the right-hand side the 1 minute. This is maybe for closely watching what's happening, and on the right-hand side, this is the interval on which the trades take place. There is my current position, profit. But of course, here on the platform, on the AI machine, this is now also taking control of this whole strategy. And you see in the upper part, you see now the live unrealized P&L, the live realized P&L. Here you see that it first entered a long position, then it entered a short position. And since it entered this short position, no additional trade has taken place. Here we see a prediction, correct downtick prediction, which means at this 1 minute bar here, 2 seconds afterwards, as we can see down there. So we have, of course, turnaround times. It predicted a downturn, and this is now green, indicating that it was a correct downtick. Now you see already, that's the reason why I like to work with the 1 minute bars. It has changed position. So the signal has changed to upwards, and we get a long position. So we started with long, it went short. This was correct here, this prediction. We realized a tiny profit, I would guess. Now it says long, and currently we have, again, unrealized, slightly positive. But overall, you see the realized P&L is still slightly negative. And if this runs now for 10 minutes, for half an hour, or let's say 3 days straight, it will take care of it all. And later on, you can analyze the success, and you can even, when it is running, change parameters. For example, here, when I say hedge required, and can define additional hedge measures and so forth. So now you see we have a slightly positive unrealized P&L here because 2 ticks have been positive. Now it turns against the signal, and you see in real time overall the strategy, because with the Wonder, of course, what we see here is for the current position the same thing. But with Wonder, you cannot really follow along the performance of the whole strategy. And the AI machine manages the whole strategy lifecycle, as we call it. So in that sense here, easy deployment, backtesting, one-click deployment. Back then, Amazon had this big push with a one-click buy. We have something like a one-click deployment, actually. And I'm pretty happy that we have come that far after more than 1 year of hard working, that it works that way. And basically any type of strategy that you can come up with, simple technical ones, simple moving averages, exponentially moving averages, blah, blah, you know them all, directional based, pattern based, machine learning, AI, whatever comes to mind. When you can formulate it based on Python, maybe we need to install a package or whatnot. But this is the smallest problem. Single instrument strategies are all easy to trade. Multi-strategies are on our list, or multi-instrument strategies like pair trading and basket are one of the next endeavors that we want to encounter. So after this demo, both of the Python side, the Python world, interactively in a Jupyter Notebook, as well as of the iMachine, now I'm coming to my closing remarks. In the meantime, I've been following the questions, but they have been mostly with regard to organizational questions. A few words about the program, our certificate program. Basically, everything that you have seen today with regard to the Python side and the background there is covered in our program. So we do proper Python teaching, programming, teach the financial data science topics, machine learning, deep learning, prediction, backtesting, streaming data, visualization, real-time online algorithms, real-time communication. And one of our major focal points is do it yourself. So we try to empower you to set up your own infrastructure and to get it up and running. So our program, I think, is one of the most comprehensive in the field when we think in terms of computational algorithmic trading, Python for algorithmic trading in 16 weeks. It's 115 hours plus. Basically, it's more than 200 hours. But I don't want to write that much because it's already hard for most people to follow along. 5,000 lines of code, probably much more, 1,200 pages of documentation. So it's a wealth of resources. And when you have a look at it here, certificate.tpq.io, there you find all the background. If you want to do all this, what I've been showing today on your own, these are the resources. I might quickly share here on the screen when I quickly open this, the links to the slides so that we have these open. So these are the two links to the slides and to the notebook, basically the same link, one time with PDF at the end, the other time with HTML. So there are certificate.tpq.io, qaweb.pdf or qaweb.html. I've shared the links with the organizers as well. You can reach out to us or you can reach out to the Algo Convention team. And I recommend that you have a look at eAlgo Convention and Algo Convention upcoming events in the pipeline. Maybe you want to join there as well. And having said that, I might get to my final slide there and can only say I'm that excited about the recent developments in our field. Data-driven finance, AI-first finance are the topics that keep me busy and up at night. I decided to start my next book project after Python for Finance with a new subtitle, Mastering Data-Driven Finance. The next will be Artificial Intelligence in Finance, a Python-based guide. So there are fantastic developments, not only for the big players in the markets, but also for the retail traders. And I'm excited. I think you should be excited too, because this is a fundamental shift, or as they call it in science theory, a paradigm shift in what is happening in finance. So the AI is now in the middle of finance, and I think it's there to stay. I would be happy if you reach out. If you have questions, feel free to reach out. I've shared the two links to the resources. Maybe one final time, I put it there. There you have also access then, of course, to the contact information. Excellent. Having said that, I wish you a good time. Happy Python coding and algorithmic trading. Hope to speak to you soon. Take care. Bye-bye.